This video is going to cover page 6. It should say page 7 at the bottom. So this is going to be all of page 6. So 1A says plot the following points on the number line without measuring. So we have the fractions 2/3, 1/6, and 4/10. So I know that 1/6 or 2/3, I can multiply that denominator by, this is kind of blurry, sorry. I can multiply 3 by a number to get 6. So remember, whenever we find common denominators between two fractions, it's a lot easier to be able to compare the two. So if I multiply 2/3, both the numerator and the denominator by 2, I can get the equivalent fraction of 4/6. So that gives us the same denominator as 1/6, which makes it a lot easier to compare them. So 2/3 or 2 times 2 is 4, and then 3 times 2 is 6. So 4/6 and 2/3 are equivalent fractions. So that tells me that 4/6 is greater than 1/6. So that also tells me that 2/3, since these are equivalent fractions, 2/3 is greater than 1/6. If we're comparing 4/6, which is also 2/3, to 4/10, we know that whenever, sorry, it's a little blurry. I don't know why it's doing that. But whenever we have the same numerator and we're comparing two fractions, the smaller denominator is going to be the bigger fraction. So 4/6 is going to be greater than 4/10. Now, if we look back at this one, when we have the same denominator with two fractions, then the bigger numerator is going to be the bigger fraction. So since we have two fractions with the same denominator now, I partitioned my number line into parts of 6. So this would be 0/6, 1/6, 2/6, 3/6, which is also equivalent to 1/2. 4/6, 5/6, and 6/6 is equivalent to 1 whole. So that makes it a little bit easier to plot them on the number line. So we're going to start with 1/6, since we know that's our smallest fraction. That's going to be slightly bigger than 0/6 because 1 is 1 more than 0. So that would be where 1/6 would go. We know that 5/10 is also equivalent to 1/2, since 5 is half of 10. So 4/10 is going to just be slightly smaller than 1/2. So 4/10 is going to go right around there, right before 1/2. And then our next fraction is 2/3. We know 2/3 is equivalent to 4/6. So that would lie on the number line right where 4/6 would go. So 2/3 should be slightly bigger than 1/2. Since we know that 3/6 is 1/2, 4/6 would be 1 bigger than 1/2. So 2/3 is 1 more than 1/2. So 2/3 should go right there. All right, if we look at B, it says, use the number line in part A to compare the fractions by writing our comparing signs on the lines. So we have our first fractions, we have 2/3, and we're comparing that to 1/2. So I know up here that we did 2/3 is equivalent to 4/6, and I also know that 1/2 is equivalent to 3/6, since 3 is half of 6. So when we have the same denominator, that bigger numerator is going to be the bigger fraction. So that tells us that 2/3 is greater than 1/2. If we look at 4/10 and 1/6, we know that 4/10 is bigger than 1/6. So if we look up here on our number line, 4/10 is right below 1/2. So one less actually than 1/2, which is 5/10. So 4/10 is right here on the number line, whereas 1/6 is kind of closer to 0/6. So 1/6 would be less than 4/10. So 1/6 is smaller than 4/10 on the number line. So that means 4/10 is greater than 1/6. If we look at 2A, it says plot the following points on the number line without measuring. So we have 5/12, 3/4, and 2/6. So I'm looking at all the denominators, because whenever we have common denominators or the same denominators in the fractions that we are comparing, it's a lot easier for us to compare and kind of plot them on the number line. So I have 12 as a denominator, 4, and 6. I know that I can multiply something by 4 to get 12. So I did that over here. And I know that 4 times 3 is 12, so I'm going to do the same thing to the numerator. 3 times 3 is 9, so 3/4 is equivalent to 9/12. And then I know that I have the denominator of 6, and I can multiply that by something to get 12. So we can have all common denominators. So 2, 6, I know that 6 times 2 is 12. So I'm going to do the same to the numerator. 2 times 2 is 4. So that 2, 6 it would be equivalent to 4/12. So now that we have all the same denominators, we can compare them and plot them on the number line. So I partitioned my number line into parts of 12. So this would be 0/12, 1/2 would also be equivalent to 6/12, since 6 is half of 12. And then 1 whole would be equivalent to 12/12. So when we have, if we look at 5/12 first, we're going to count 5 on the number line. So 0/12, 1/12, 2/12, 3/12, 4/12, 5/12. So that is 1 less than 1/2, which 1/2 is equivalent to 6/12, which 5 is 1 less than 6. So 5/12 would be right here on the number line. And then if we look at, let's do 3/4 now. So we found the equivalent fraction of 3/4 with the denominator of 12. So 3/4 is equivalent to 9/12. So if we count 9 on the number line, let's start with 6/12, which is 1/2. So 6/12, 7/12, 8/12, 9/12. So we know that 3/4 is going to be right where 9/12 is on the number line. And then if we look at 2/6, we know that fraction is equivalent to 4/12 with that denominator of 12. So that's going to be where we are going to put it on the number line. So 0/12, 1/12, 2/12, 3/12, 4/12. So that's where 2/6 would lie on the number line. If we look at 2b, it asks us to select two fractions from part A and use the given number line to compare them by writing our comparing signs. So I did it with both fractions. So 2/6, I see that is less than 5/12 on the number line, slightly less, not a whole bunch, but that still means that 2/6 is smaller than 5/12. And then if I look at 5/12 on the number line compared to 3/4, 5/12 is less than 1/2 and 3/4 is greater than 1/2. So that tells me that 5/12 is going to be less than 3/4.